I will start my presentation by making a quick argument that AI is really not new in education. Forgive me if this is already familiar to you, but I think many people don't realize just how pervasive AI or machine learning applications are in education for a long time now. So here are a few examples of those. Automated grading is one that's perhaps widely known. Applications like Gradescope and massive open online course platforms like edX and Coursera implemented ways of automatically grading, which was a key to their scalability. Going with automated grading, plagiarism detection, right? Figuring out if students just plagiarize from somewhere on the internet uses machine learning algorithms as well. One perhaps most popular example are intelligent tutoring systems. These are systems that try to adjust the difficulty of the questions that are given to students based on their estimated knowledge state, right? So if I get a question right, the algorithm updates and its beliefs and thinks that I know more, and it gives me harder questions over time, or it ends the block of questions early because it has determined that I have mastered the skill that I was supposed to learn. Systems like Carnegie Learning and Alex are widely used in schools across the United States. Similarly, but slightly different, are adaptive learning platforms that are tailoring content based on students' actions in the system. So Smart Sparrow and Newton are examples of that, where students unlock different parts of the content. They might skip parts of the content if they demonstrate mastery over certain components. So all of these use machine learning algorithms in making those determinations and shaping the way that students are learning. Another very popular one that has been out there for a long time now is speech recognition in the context of language learning. Duolingo, Rosetta Stone, many others have used algorithms to perform recognition of language and whether students are close enough to the right answer. Grade and dropout prediction is a very commonly used type of model in higher education, but also in K-12 schools. Civitas being perhaps the most widely spread provider of dropout prediction models to higher education institutions, analyzing a lot of data as to how students are behaving at a university to make predictions as to who's at risk of not returning the next semester or the next year. And Bright Bytes used to do the same thing in the K-12 space. And this is just a sampling of examples, but it's important that this is, this is not new. And therefore also not new are questions around responsible AI in education. So even pre-LLMs, we've been concerned about the issues of student surveillance, the kind of features that are used in the algorithms that I just described. For instance, some algorithms use student movement data using their cell phones, or where they swipe their cards, which Wi-Fi connectors they connect to as they move around campus. And there's legitimate concerns there around surveillance. Relatedly, student privacy and data protection. When, for instance, a university hires a company like Civitas, they provide them with a lot of data under the FERPA exception, usually for school officials, where then the company is becoming a school official providing these services to the university. But there's still a lot of data that gets transferred and gets exposed to third parties. Transparency and explainability has long been an important consideration in this space. For instance, why is an essay marked as an example of plagiarism? Also, what are the factors that are contributing to a dropout prediction, which can influence how an instructor or an administrator might respond to that prediction. And then, of course, a lot of questions around bias and fairness with respect to sensitive student data, right? Is the model fair? Is it advantaging some students over others in its predictions? And that's, in education, I think some of these questions are slightly different than in the rest of the literature, because what a bad outcome is not as clear as it is in some other contexts. So for instance, if we're looking at dropout prediction, I might be wrong in flagging a student as likely to drop out, but the support that is provided to that student might still be helpful to the student, right? So that false positive might not be as problematic as in some other contexts where false positive are have a lot of more consequences, such as denying somebody a loan application. And then finally, ethical use. So how you use these predictions can vary a lot. There are some examples of institutions predicting whether a student is likely to be able to pay their student loan and making admission conditional on those predictions, which you might think is unethical behavior. There's also questions around how the people who are in the end reaching out, how they interpret the data at this intersection of human AI interaction. So this is just a sampling of questions that people in the AI and education and learning analytics and educational data mining and related fields have been grappling with over the last many years before even the LLM revolution has started. But speaking of which, generative AI has very quickly entered education, and to many, it's been the promise has been sort of this personal tutor that we've been investigating for a long time in this literature, inspired by books like Diamond Age and Bloom's early studies on the 2 Sigma tutor, who can be there for you, help you out, answer your questions, and really help you learn much faster and more robust. So that is how a lot of people have seen these tools as a way to promote that. And we've seen quickly companies such as Duolingo, Khan Academy, and many others implement almost overnight services that will provide students with a chat experience that tries to resemble that kind of personalized tutoring. And that has a lot of benefits, right? I think there are a lot of opportunities of generative AI in this space. I don't use the term lightly, and I will explain to you why I think this is the case, but there is a real potential for a paradigm shift in education, in particular in how we think about learning outcomes and how we think about assessment. I'll spend more time on that later in the presentation. In addition, there's much opportunity for assistance in many activities that students are doing. I used an AI tool in my own teaching. I teach a large class on learning analytics, essentially a class at the intersection of data science and learning theories, where students do a lot of work on educational data, building predictive models, analyzing the data. And it's students often get stuck as they're solving problems, and office hours take a long time. They're inflexible. Having AI tools there in the class that are able to answer students' questions 24/7, help them get unstuck and move forward with their exercises is really helpful. Personalized learning, the idea that we can understand what the student needs, what the student's interests are, what is relevant to a student, and be able to match their level of experience. Similar in some ways to what intelligent tutoring systems have done when it comes to prior knowledge and the knowledge state, and but in a much more relevant way, right? Such as asking students, well, what sports do you like, or what activities do you do after school, and then giving examples that are tailored to that. There's a lot of opportunities in that space, which we know is helpful for motivation. Accessibility, we're already seeing a lot of students use AI, generative AI for accessibility, having summarizing information, translating for not native speakers, native English speakers, a lot of different ways that students are using it in order to overcome previous challenges. And not to forget, there's instructors in the loop who are asked to do a lot of things in providing materials, providing assessments, helping students move forward in their classes. There's a lot of opportunities here for how to scale constructive critique of students and help them iterate and learn, hopefully faster and more robustly. And I'll unpack a lot of these in the presentation. But first, the negative sides, and we touched on a few of the pre-LLM negatives already, but There are some that are quite specific to generative AI. I'm sure this group is very familiar with these, but there are some nuances for the education domain, as I will argue. So one is, of course, misinformation, toxic output, biases in the output, and there's still a very open question around copyright that has to get resolved around the information that is being provided and where it's sourced from. Different countries have been leaning different ways there, but we'll see how this will shake out over the next few years. The other one is affordable access, right? There is a sense that these tools are going to be useful for students, that students are going to benefit from it, but also a sense that not everybody has access to the best models to do this, right? And there's a real question around whether universities can step in to provide access to these models, like universities for a long time have provided access to libraries as a source of information. And universities have been built around libraries in the past for exactly that reason. A third concern that is really relevant here, and I'll get into a bit more, is that of over-reliance and overconfidence. Students over-relying on generative AI tools, perhaps even becoming less willing to interact with peers and educators. A colleague of mine did a survey of whether students would prefer to have an LLM or access to a TA. And students, the majority of students preferred the LLM because it was 24/7 available. They thought they could have easier conversations with it. So there's a real question around how students are going to end up using it. And that is certainly something that educators and institutions of education have influence over in how they suggest and educate them to use these tools responsibly. And finally, a big one is academic integrity violations that not only raise serious concerns for the credibility of credentials that universities and high schools are providing. There's some strong evidence to suggest that current assessments are simply not valid anymore as ways of credentialing students' understanding and knowledge. But also really for the learning itself, right? So putting aside the question of credentials and focusing on students' learning, there's a number of papers that have come out in recent years now suggesting that LLMs can undermine learning if students are circumventing the learning processes. It can do nothing for learning, or it can potentially help with learning when it supports students in situations where, for instance, they're engaged in unproductive struggle, where they're just sort of banging their head against the wall and not really moving forward in a helpful way. I want to start with focusing on bias in LLMs, which is of course an important topic, and I want to look at it with in terms of educational settings. And one piece of this that's really important in a global educational system is culture and the voice that an LLM presents. So I'll show you an example first, two studies. One that focuses on cultural values that that LLMs seem to portray, and our ability to control them. And while this is not specifically an educational setting, you'll see the implications of it, hopefully, in just a little bit. And so in this study, we leverage a benchmarking data set, which is called the World Values Survey, which is a large survey that has been conducted for many years now across well over 100 countries, and that asks people questions that about various aspects of culture and norms. And this has been summarized, those questions have been summarized to establish two dimensions of culture. And by summarizing all of those responses, we're able to map countries around the world onto this two-dimensional space in terms of their culture. And researchers have tracked for decades now how this sort of scatter plot has evolved over time as cultures have evolved as well. So I'll show you what this looks like. You see here a recreation of this map, this cultural map. On the x-axis, the survival versus self-expression values. On the y-axis, the sort of traditional versus secular values. The x-axis is a lot about sort of freedom of speech. The y-axis is sort of more about religion and traditional values, for instance, around homosexuality and other values that people might hold. And you see a point for each of the countries in the sample here with clear clusters, and people have pointed out how cultures with similar countries with similar cultural values have clustered together. And what we did is we took the same questions, which boils down to really just 10 questions that are most representative, and we asked those questions to the last let's see, 1, 2, 3, 4, 5 versions of OpenAI's LLMs, in part to understand how their values have evolved, just like the World Value Survey has studied this. And what we find is that there's very little variation in terms of self-expression values. They're highly self-expressive, very much answering those questions in terms of believing in freedom of speech, expression, but somewhat more variation in terms of how traditional secular they are. Although I point out that zeros is sort of a pretty neutral point on this, and so it's all around that neutral point, around sort of not saying too much about opinions about sort of believing in religion or homosexual, beliefs about homosexuality being allowed or not, but rather sort of trying to sort of split the difference as much as possible. We've tried to make this as robust as possible. We asked the questions in a number of different ways, changing wording, averaging between them, and this is what we found. Now, the question that was really important to us is, if you are from a country like Tunisia or Moldova, can you make the LLM respond in ways that is more like those values in your country, right? Can you control the LLM to align better with you? And so we ran some experiments on this using what we call cultural prompting, essentially just saying, respond like someone born and raised in this country. Right? The full prompt is in the paper. We tried a few different variations, but the result is very consistent, which is that, yes, it does work to an extent, and it does work especially well in more recent models. Right? So you see GPT-4, 4 Turbo, 4o, you see a significant reduction here in the distance between the your country and the LLM response when you have it sort of the default, where you don't say respond like someone from my country, versus when you have the when you add cultural prompting to it, right? That distance gets reduced. That's what that scatter plot, that box plot shows there. So that's promising. But what's important here is that, I'm talking about people, an LM responding to some survey questions, right? And there's been some debate as to how valid that is. It's useful. We can map it. It's a nice benchmark. But let's look at some real text output and see how LLMs respond. And so what's important to note here is that there's a long tradition of looking at voice and how people express themselves, in particular when it comes to speaking, right? Speaking is associated with people in power, and there's sort of a way that the way people are speaking becomes a standard, right? For a long time, we've used the phrase standard American English, right, as if that was sort of the right way to talk, and contrast that to things like African American vernacular English, right? Sort of using the word vernacular to make it sound even less standard than it is, right? And so we've moved away from some of those labels, in part to not suggest that there is one right way to do it. Linguistic styles that deviate from this have been evaluated poorly, right? So not writing in professional English is seen as less good, and how people write is very much correlated with their race, their social class, has or how people speak, I should say, has been very much associated with those things, and demonstrated in the literature. But while a lot of this work has focused on speech, we now live in a world that is saturated in text, right? And LLMs really exemplify this. So the question this raises to us is, what type of writing style do LLMs represent? And there have been a few studies that look at this from different angles, from the angle of dialects, from the angle of racial differences. I want to show you an example now in the context of education, in a high stakes context in education, which is that of admissions. So Here we're looking at admissions, college admissions essays at an R1 university in the United States. And what you see here is taking these essays and representing them in different embedding spaces. And I show you 3 different ones because I just want to highlight how robust this finding is. We've tried a lot of different things to sort of see something different. It all turns out to look the same, really. And what we did is we took the real essays that students submitted over several years on their college applications. And then we asked different LLMs, here I'm just showing you one example, but they're very consistent again, to also write an essay with the exact same instructions. And what you see is that the human essays in green are very distinct from the LLM written essays, right? They just write in different ways. They use different words and they use different sort of semantics than the human essays, right? As you can see on the right-hand side with the SBIRT embeddings. And so we've tried this a lot of different ways. One other thing that's that you almost don't see, which is actually really interesting, is that there's these red dots and the blue dots. The blue dots is really just giving the LLM the instructions to write an essay with a given prompt, whereas the red dots are asking it to take on a certain personality. So like we did with cultural prompting, in this case, we give the LLM, write like we use the same from the human essays. We had the demographic data, like a female first generation Black student from Illinois, for instance, right? And we sort of ask it to take on that person. As you can see, it makes almost no difference. If you compute the distances and you sort of do the math, it is a little closer, but negligibly so, really. So here we don't see as much evidence that the LLMs right now, at least, are able to be controlled in such a way that it aligns with the voice of real human essay writers. Some other evidence from a related study that we've done, and I'll go through these a little quickly because there's sort of some bigger points here. One is, we're comparing once again here human essays with GPT written essays. Here are 2 different ways of representing the text using Luke, which is a dictionary-based approach for representing the prevalence of different types of words in the text. On the left-hand side, you see essentially the prevalence of long words, 6 letters or more. What you see is that the human essays, those 2 distributions on the left, very different from the GPT-written essays, the distributions on the right. And here we have essays from a public university and a private university, right? So very different words being used or length of words being used between the 2. However, when it comes to specific vocabulary, and I show this example as an exception, not as a rule here, there is some more commonality. So affiliation words to talk about community, belonging. The essays, they're not as common as you can see from the x-axis, but there's a little bit more alignment there between them. However, overall, in this study, when we compared essays from these 2 institutions to GPT-written essays with the same prompts, we see a lot of differences between them, right? We try to figure out, are they more male or female? But as you can see here, the male and female essays are very close to each other and both very different from the GPT-written essays. We also see that there's much more distribution in the linguistic variation in the human essays than there is in the GPT essays, which tend to be a lot more similar, right? The distribution is much tighter, as you can see here. And we see that human essays, this is on using the economic connectedness index that Raj Chetty and colleagues have developed, which is a good measure of sort of socioeconomic status. Those human essays tend to not sound as affluent as the GPT-written essays in terms of the words that they use, based on predicting from the essays the zip code that an essay author would live in based on the words that they're using in their essays. So so we see a lot of evidence that AI-written essays do not sound like students, and that raises important concerns around the way students using them and how it changes the way that the student's voice gets represented in educational settings and beyond. As we were doing these studies, we were thinking a lot about the ways that bias and fairness concerns enter into AI models, into LLMs in particular. And it's hard to pin down exactly where biases come in, that because there's a lot of different places where it can happen. So we're really inspired by the work of Suresh and Gutak, who developed this really neat life cycle model for more traditional machine learning approaches. And we attempted to do something similar for LLMs. But there we need really two different phases. There's the training the base LLM, which most people don't have to worry about, right? They take one off the shelf. And then there's the customization of the LLM. But we've still tried to map out both of these phases in this work. One here is the training of the base LLM with a lot of biases, historical biases, representation biases, and how you sample, measurement biases in the pre-processing, learning and aggregation biases in training the models. If you're bringing in general purpose fine-tuning using human rankers, for instance, you've got learning biases as well as human feedback bias, and then various evaluation biases that come in from red teaming efforts or evaluation benchmarks that are being used. But where it gets much more relevant to most stakeholders is in the second phase, where somebody takes a base LLM off the shelf, maybe a llama model or something else, and tries to customize it, right? So here we've got some of the same biases coming in, but a lot more going on. There's a lot of sources where things can go awry, and pinning them down is difficult. But here we tried to map them out as best as we could. I could spend so much time going through all of these, and the paper does go through all of these and gives examples of all of them. I just want to let you know that we've done this work, and hopefully people find it useful in trying to map it out. And if you have comments on what's important that's missing here, we're happy to learn more and update it as we go along. So one of the things that is important, though, is that what educators, the teachers, the instructors in the classroom perceive as harms and are concerned about as harms may not be what us researchers and ed tech developers are thinking about, right? And I'm a strong believer in really listening to instructors and educators to understand their experience. They know best what students are doing, what the challenges are that are being faced in the classroom, how AI is affecting what goes on. So education, I noted before, is a unique domain, and in part that's because we're serving children, young adults who might be very impressionable by what they're seeing with AI. The second is that the goal is not always to give the correct answer. It's really to understand how somebody gets to the answer. My colleague Justin Reich likes to say that on the internet you answer questions, but in the classroom you question answers, right? You ask a student, well, why did you say that, right? How did you get to that conclusion? And so we, in education, we really try to promote higher order skills, not just give the right answer. So there's a lot of important differences when you think about LLMs in this context. My student Emma Harvey has led this work on understanding sort of the difference, the potential misalignment in what edtech providers are thinking about in terms of harms and what educators are thinking about in the classroom. So she interviewed 23 educators and 6 major edtech providers that really account for a lot of edtech being used in K-12 classrooms, and asked them about sort of what they are concerned, which harms they're concerned about, and what they're doing about them. And what she found is that there's a really substantial disconnect between what the concerns are and what providers are doing, right? You see at the top here, technical harms. That is what providers are really focused on, right? The kinds of things I just talked about. Those are the things that providers are worried about. But when you ask the educators, they are much more worried about issues of academic dishonesty, about broader impact harms around increased educator workload, inhibiting social development, exacerbating inequalities. And so it shows that there's an important need to listen to educators and make sure that we address the concerns that they have, not the maybe more abstract concerns around sort of bias in an expert embedding of the text that is provided, right? Albeit important. So I'll focus briefly on the academic dishonesty component, which is clearly an important one that a lot of people are thinking about. We conducted a survey asking students and educators to have both voices represented, the same questions, around what type of assessment do you think is most affected by generative AI. And there's agreement that assessments that ask students to write computer code, mathematical proofs, essays, reports, literature reviews, and short answer questions are probably most affected. And we did the survey across in 3 different countries at institutions in those countries. We also asked students, educators and students how they think they would use generative AI tools to complete, as an example, an essay writing homework. And educators immediately jumped to the conclusion that students would use it to just generate the content, write me my essay. That's what the majority of educators thought was going to happen. But when we asked students that same question, we saw much more diversity in responses, right? Some said, yes, I'll generate some parts of my essay, but I said, I want to get somebody to bounce ideas off, right? Generate ideas, help me reword and revise my writing, and maybe learn something in the process. So I think that's important to keep in mind that students are thinking about this as a tool to assist them, whereas maybe educators might be slightly too pessimistic at times when it comes to how students would use it. I want to share with you some in preparation work, because it is really the most credible estimate of AI-assisted cheating that we have to date. It's the result of a list experiment, which is a commonly used way to get credible estimates for socially undesirable behaviors, right? Where people would be motivated to lie about their activity, such as cheating. And so this has been used in many other studies to get at the credible estimates for this. Over 100,000 students across 20 major universities participated in this. So on the x-axis here, you see results of this survey for how much they use generative AI. So it's the proportion of students using it weekly or daily. This survey was done just a few months ago, was concluded just a few months ago. And on the left-hand side, on the y-axis, you see AI-assisted cheating prevalence. So 0.1 is 10% here admitting to it. You see 8% around is sort of the students, saying, I am using AI to cheat. This is this is not sort of, maybe, it's just very clearly, I know I'm cheating using AI. So that's sort of where that percentage is. Maybe lower than some might have predicted. But what's important here as well is that there's a lot of variance across different subject areas, right? And it's the subject areas that I just showed you that students and educators think that students are using AI more, right? Computer science, mathematics, economics, business, engineering, right? The places where you're writing code, you're doing proofs, that is where we do see more generative AI use, actually. And we're also seeing more cheating. So it raises the important question, given that there is this concern about academic dishonesty, we're seeing some evidence of it, although maybe less than we thought. How do we enable teachers to trust in AI in education, to try and get on top of it, control it, help the students use it responsibly, right? So we conducted a study across 7 different countries, a survey study, surveying educators in those countries about their beliefs of AI in education. The model that we use is one where we, very simply say, trust in AI in education is affected by their perceived benefits of it and their perceived concerns of it, right? And so we wanted to understand what influences these perceived benefits and concerns. We investigated a number of factors: self-efficacy, right? Whether educators believe they know how to use it, understanding of AI, how much they understand what it is, even professional experience in teaching, their cultural values, socio-demographics of the educators, and where in the world they are. And what we found is that not that many things are actually predictive of these factors and in turn trust. Self-efficacy and understanding were the 2 most important ones, followed by cultural values. The others were really not predictive of perceived benefits, perceived concerns, or trust. And so this to us really suggests that it's important to to develop AI literacy for educators and to promote culturally responsive AI to align with cultural values. So that's where sort of the cultural piece really comes back in as being important. But developing AI literacy is critical so that educators feel confident enough to introduce it into their curriculum and manage it effectively. And to achieve that, I think what has been missing in the study, but is critical, is understanding the contextual factors, right? What is the institutional support that educators have? What technical resources do they have to even use these tools for, in ways that does not impinge on students' privacy? Having learning resources for educators and students, and having a community of practice among teachers to iterate on different approaches. But I want to come back to the other part that Emma identified in her great study here, which is that of broader impacts, the other things that educators are really concerned about. And in particular, it highlights that there's an opportunity for rethinking learning outcomes and a requirement for reforming assessments, right? Educators are concerned about students learning less, about students not developing the right skill sets anymore because they're circumventing learning. And so, I do believe that educational institutions will need to integrate generative AI into the curriculum. I think that's inevitable. And instructors will need to integrate it into how they structure learning and assessment processes. And there's a lot of great ways, right? We talked about individualized practice, help tutoring, making learning more culturally relevant with culturally relevant examples, generating materials that allow students to engage in more active learning rather than passive learning, allowing students like calculators have in mathematics, allowing students to sort of skip some of the lower order skills and focus on higher order skills, and practice using generative AI as a tool for when they enter the workforce as well. But it raises a question. This all sounds great, but are current generative AI models ready to take on these challenges? And I think that's where a big opportunity lies for us, and a big need really lies, which is that to create LLMs and large multimodal models that are optimized for education, right? There's efforts now from a bunch of different sides to try and think carefully about what would those models look like. How do we train them? How do we fine-tune them? How do we optimize them for educational use cases? And so I'm really excited that we'll be starting with support from the Gates Foundation and the Chen Zuckerberg Initiative, what we call the National Tutoring Observatory at Cornell, with partners at CMU, MIT, and RAND, to provide a new data set and refined models for education specifically. And we're going to do this in partnership with tutoring providers that are already recording a lot of data about students interacting with tutors at the moment. And it allows us to sort of create really the largest data set of human tutoring that we have so far. And there aren't many at the moment, right? There's a lot of data about what students are doing. There's very little that tells us what good tutors are doing or good teachers are doing. And so we're hoping to take a lot of this data, works with some of the gnarly data privacy issues, de-identification issues at scale, and be able to create the Million Turing Moves data set. So I think we're in the midst of designing the future of education. Some people point to the pandemic as an important time in education where things have changed dramatically. I don't think they have. The pandemic, we were able to go back to normal because sort of nothing changed in such a way that we couldn't. With generative AI, that's different. We can't go back to normal, right? We can never take away the ability for a student to just take the essay prompt and say, write this for me, right? And so we do need to change things. And in particular, the nature of assessment, I believe, is bound to change in the next 10 years or less, because we cannot ignore the fact that just assessing the final product is relatively meaningless when the final product can be created at a click of a button. It's about the process. And learning scientists have always been interested in understanding the process, but it's been hard to assess. What's not going to change much is how people learn. How people learn is very much ingrained in how our brains work, and those haven't changed in the last 1,000 years. And so, we cannot skip learning, right? And that's what I think some of these papers have shown, that show sort of reduced learning. When the LLM is used, or the AI is used in a way that skips learning processes, we're just going to see less learning. So we need to make sure we enhance learning given our understanding of how the brain works and how learning works. And I think that institutions of education will play a central role in promoting responsible use of generative AI. And so partnerships with institutions of education, with departments of education, will be critical in making sure that curricula are designed in such a way that promote that kind of learning, and that assessment reform is implemented successfully.